All right, in this video, we're going to take a look at variance and standard deviation of a probability distribution. So in our last video, we took a look at the expected value or the mean as a measure of center for our probability distribution. In this video, we're going to take a look at measures of spread. So previously, when we talked about measures of spread, we saw that variance, which is the average squared deviation that the data values are from the mean, was the sum of the squared deviation values divided by the number of observations, so n in that case. Again, mu for the population mean, and again, because we are going to be dealing with a probability distribution which takes into account all possible outcomes, we'll be using the population parameters with mu and also with n in the denominator for variance and standard deviation instead of n minus 1 like we looked at for samples. Well, for variance for probability distributions, it's very similar to it. So sigma squared for variance, it's going to be the sum of the squared deviations times the probability of each observation. So we calculated the mean in the last video with expected value. So what we'll do in this one is we'll subtract that mean from each of the observations, square the result, then multiply that result by the probability of the observation for that particular row. And then when we get done doing all the rows, we'll add them all up and we'll have our variance. And as always, to get standard deviation, just take the square root of variance. So as an alternative form of the variance and standard deviation, instead of the mean, the mu value, we could use expected value of x. So again, expected value of x for a probability distribution is the same as the mean of that probability distribution. And again, standard deviation is the square root of variance. So what is the standard deviation of rolling two dice? So in our previous example, we saw that the mean, or the expected value, when we roll two dice, is 7. So for the value of 2, rolling a 2 on two standard dice, we take 2 minus that expected value of 7 and square it, and then multiply it by the probability of obtaining a sum of 2, which is 1 out of 36. So 2 minus 7 is negative 5. Negative 5 squared is 25, and 25 times 1 over 36 is 25 over 36. For 3, we take 3 minus 7 and square it. So 3 minus 7 is negative 4. Negative 4 squared is 16. And the probability of obtaining a sum of 3 is 2 out of 36, or 1/18. So we have 16 times 1/18 is 16/18, or 8/9. And we're going to continue to do that for all the values up to and including 12, which 12 has the same outcome as 2. 12 minus 7 squared times 1 over 36 also gives us 25 out of 36. And so our variance is, we're going to have to add up all these values from 2 through 10, all those different outcomes. And then for standard deviation, which is what we're looking for, we take the square root. So adding up all those results and then taking the square root, we get our standard deviation for rolling two dice as 2.415. And again, if instead of looking at the individual probabilities, we instead just listed out all the outcomes. So again, we have one occurrence of a 2 in our table, 2 occurrences of rolling a sum of 3, 3 occurrences of rolling a sum of 4. If we just go and calculate our standard deviation of this population here, then it should come out to equal, I believe it was 2.415. So let's just see. Yeah, 2.415 as our standard deviation. And if we were to repeat an experiment and roll two dice, let's say several million times, then write down the sums in a list and then find the average or the mean of the sums in that list, then our standard deviation would get closer and closer to this 2.415. But do bear in mind that our value of 2.415 is an approximation here, so this is rounded to 3 decimal places. All right, so that about does it for this video. Thank you for watching. I will see you next time.